Hey everybody, today I'm just going to do the answer key and videotape myself doing it. Let's see if that helps. So for the first one, 2u plus 3v, we simply take u, multiply by 2. So 2u would be 6 comma negative 4. Same thing for v, 3 times v, just multiply the individual components by 3. Get negative 15 comma 3. Since we're now adding them together, just add them. So 6 plus negative 15 is negative 9, and negative 4 plus 3 is negative 1. That is problem 1a. Problem 1b, find the unit vector for u. So the first thing we need to do is find the magnitude of u. The magnitude of u is 3 squared plus 2 squared, all square rooted. So that would be rad 13. That makes the unit vector equal to 3 divided by rad 13 and negative 2 divided by rad 13. If we rationalize this, it would be 3 rad 13 over 13, comma, negative 2 rad 13 over 13. Now, part of the point of me giving you this problem is to see if some of you just realize that the unit vector for 3u must be the same as the unit vector for u since it's going in the same direction. But let's say you didn't see that and you wanted to find out the unit vector of 3u. So vector u, or 3u, would be 9, negative 6. If we find the magnitude of 3u, it would be the square root of 81 plus 36. So 110, 127. So let's see if anything goes into that. Oh, sorry, 117. I knew that 3 was supposed to go in there. All right, so 117. 9 goes into 117. So the square root of 117 would be 3 times radical 13, since 13 times 9 is 117. And then if we take the vector 9, negative 6, and divide those, these cross off, we get negative 2, and we end up in the same place that we got here. So you can see that in the end, both unit vectors end up being the same value. Okay, part C, find a vector orthogonal to V. So if we're at negative 5, 1, that would be 1, 2, 3, 4, 5, 1, a vector that looks like this. So just thinking about it from a slope perspective, this would have a slope of negative 1/5. A vector orthogonal to that would have a slope of positive 5 opposite reciprocals. So if you just think about it from an algebra perspective, if we go up 5 and over 1, that must be orthogonal. The vector would be 1, 5. To prove this is orthogonal, you can do the dot product. So if we do 1, 5 dot with negative 5, 1, it would be negative 5 plus 5, which is 0, which proves they are in fact orthogonal. The final problem here, the vector, or the angle between the two vectors. The formula I'm referring to here is cosine of theta equals u dot v divided by the magnitude of u times the magnitude of v. So u dot v, the dot product is multiplying the x values, that would be negative 15, plus the y values multiplied, that's negative 2, divided by the magnitude of each vector, which would be rad 13 times rad 26. So now we're going to take the inverse cosine of that. I'm getting 157.6. So let's see if that seems to make sense with our vector. So u is at 3, -2. Right there. And v is at -5, 1. So we're talking about the angle formed between those two. So from there to there, 157.6 does seem to be like a realistic number for that. So that checks out, and that's the answer. Okay, I'll make another video for the backside.